about being able to find the margin of error, or given the margin of error, finding the sample size. So there is a formula you need to remember. For margin of error, it's very short and simple. It's simply plus or minus 1 over the square root of n. And in this case, an n is the sample size. N is the sample size. These are nice, easy, quick problems. They should be. Do you recall where you've been dividing by the square root of the sample size? Because we've done some activities and done some intense things with the central limit theorem. Do you remember when you divided by the square root of the sample size? What was it to find? Exactly, very good. So that standard deviation, that variability, that fluctuation that happens, because you can't control it, right? Sometimes when you take a sample, it's not going to exactly represent the whole population. There's going to be some variation. That standard deviation is your margin of error, okay? So it's plus or minus 1 over the square root of n, where n is the sample size. So let me put this into context with elections. So for example, let's say Mr. Sanders, so 32% of voters, let's say in California, 32% of voters will choose, let's say we did a exit poll and we found out that you hear on the news, okay, 32% of voters will choose Bernie Sanders with a margin of error of plus or minus 6%. That's how you might see a margin of error, plus or minus 6%. So 32% is what we think will be true for the whole population, but we're not sure, right? So margin of error plus or minus 6%. So the question is, how many voters will feel the burn? Okay, so let's figure that out. This is really simple, right? You take your 32% and the margin of error, right? Plus or minus 6%. So you subtract 6% to get the lower extreme, and then you take 32% and you add 6% to get the upper extreme. So the answer is between 32 minus 6. 26% and 38%. Okay, so that's one way of asking. And then the other is, B, with that margin of error, what was the sample size? So what was the sample size? So we just work backward. We're given the margin of error of 6%, right? You plug it, you set it equal to 1 over the square root of n and solve for n. That's all you do. So but you have to do it carefully though, okay? So the margin of error was 6%, so you just go like this. Watch, you do 6%, 0.06, right? Make sure you put it in decimal, okay? 6% is 0.06 equals 1 over the square root of n. All we're going to do is solve for n. Solve for n, and we'll know the number of people that were surveyed in this. Okay? So now how do we do that? So step number 1 is to the easiest thing to do is square both sides. To get rid of the radical, you just square both sides. So you get 0.06 squared equals, when you square 1, that doesn't change, and you just get 1 over n. Okay, that gets rid of the radical. 1 squared is 1, and square root of n squared is just n. And now we really just need to square that. I'll do one step at a time. I won't skip anything. 0.0036 if you square that. Okay, and this is multiply both sides by n. It's fraction busters. Or you could cross multiply. You could put this over 1 and cross multiply, but that's a little fishy. So I'm going to multiply both sides by n. I'll keep going here. 0.0036n equals 1. And then you divide both sides by 0.0036, right? So your answer is 1 over 0.0036. If you do it carefully, one step at a time, you will get 277.8. Can we have that many people? No, right? We need integers for people. So do we round? You always round up, okay? Because you want to err on the conservative side, and the higher, the larger your sample size, the better your results. So always round up, no matter what. Even if it was 277.1, I'm going to round up. I would prefer sampling more people than less. It'll have a better margin of error. So 278 people. So we're gonna practice that one more time, and then we're gonna go in the other direction. So let's say, why don't you try this one? Let's say we have, this is just gonna be out of context now. This is just the skill here. So let's see an example. Let's say margin of error is find sample size. These are the two directions you'll go. Find the sample size if you can abbreviate margin of error, okay? Margin of error equals plus or minus 10%. Okay, find the sample size. Do we expect the sample to be larger or smaller than it was before? With a margin of error of 6%, we sampled 278 people. So if our margin of error is wider, are we sampling more or less people? We're actually sampling less people because there's less certainty, right? We want a small margin of error, right? You want your answer to be close to correct. So plus or minus 10% is not better. You know, plus or minus 6% was a better margin of error, right? You want the smallest margin of error you can get. And the way you're going to do that is increasing your sample size. So the last problem we did, we had a margin of error of 6%, and our sample size was 278. You solve for a margin error of 10%. So go ahead and do that. Alright, and then the other direction we can go in is to find the margin of error given the sample size. So what if n equals 3,000 people? This is the easier direction to go in. All you have to do is plug it into the formula, plus or minus 1 over the square root of n. Alright, you just want to find the margin of error. So what do you think it's going to be if you can sample 3,000 people, roughly? Remember 6%, we sampled 278. So if we can sample 3,000 people, what do you think the margin of error will be? Pretty small, right? Okay, so let's see how small. So we're going to do plus or minus 1 over the square root of 3,000. If you just type that in carefully on your calculator, you'll get plus or minus 0.0182. But be very careful, okay? Please don't, that is not your answer. It's not that small. What is it supposed to be? It's a percent, right? That's the decimal. So what's percent? Move the decimal to the right 2 places is 1.8%. That's right. So we'll do one more of those. If the sample size, let's say, is really small, right, like 5, now we're going to get a huge margin of error, right? We're only sampling 5 people. Let's see what we get. Plus or minus 1 over the square root of n is plus or minus 1 over the square root of 5. You'll do that on your calculator. You'll get plus or minus 0.447. That doesn't look big. Because what's the answer? 44 point. That's like basically like, why even bother? Like, if your margin of error is plus or minus 44%, I don't even want information from you. Okay.